Hey guys, in this one we're taking our first look at transformations of graphs. So there's quite a few of these, each different type is going to get its own video. So we are looking at starting with a function f of x and then sketching the graph of the transformed function. So here we are looking at translation. Now there are two different types of translation. There's translation along the x-axis, so left and right, and there's translation along the y-axis, which goes up or down. So the shape of the graph does not change when we do translations. Purely, it's only the location of the graph that will change. So, first up, if we take a graph y equals f of x and we transform it to y equals f of x plus a, so the a is not inside the brackets, then this is a translation along the y-axis. Now the translation vector for this is 0, a. So, if a is greater than 0, i.e. positive, then this is a positive translation up the y-axis. So when a is greater than 0, the graph moves a places up. So, for example, if we had f of x plus 5, then the graph would move 5 places directly upwards and the vector would be 0, 5. If, on the other hand, a is negative, so less than 0, the graph moves directly downwards. So, for example, if we had f of x minus 7, then this is going to move the graph 7 places straight down, and the vector for that is 0, minus 7. So that's what y translations look like. Quite straightforward, quite intuitive. Now when we get to x translations, this is where it gets a little bit counterintuitive, which maths likes to do. So x translations are of the form f of x plus a. So the a here is inside of the bracket with the x. Now you would think probably f of x plus a is going to move positively to the right by a places. Seems logical. It's wrong though. Now this is where it starts to get counterintuitive. So if we want to sketch the graph of f of x plus a, this actually moves a places to the left, bizarrely. So in general, the translation vector for f of x plus a is 0, no, sorry it's not, it's minus a 0. So this is quite a tricky one to wrap your head around. Let's go through it. So when a is greater than 0, this translates the graph a places to the left. So, for example, f of x plus 2 moves the graph 2 places to the left. Vector minus 2, 0. Or, on the flip side, if a is less than 0, so it's negative, then this moves the graph a places to the right. So, for example, if we had f of x minus 5, that moves the graph 5 places to the right. Vector 5, 0. So, with the y translations, it's very intuitive. It works how you would expect. With the x translations, I would say it's fairly counterintuitive. It probably works in the opposite way to how you expect it to. So negatives move it positively, positives move it negatively. Now, if we think about why this happens, I'm a big fan of the y's. So, let's say we had f of x, could start f of x was equal to x squared. And then we're also going to have f of x plus 1. So f of x plus 1 is just x plus 1 squared. Now, let's make ourselves a little table here. If we were to put in x equals 0, then f of x squared, would be 0 squared. So that's just going to be 0. But if we put in f of x, or f of 0 plus 1, then we've got 1 squared. So that's 1. If we had x was equal to 1, f of x would be 1. F of x plus 1 would be 2. So what's happening? F of x plus 1 is making the y values happen one place earlier. So everything is happening one place earlier along the x-axis, or the y values are happening one place earlier along the x-axis. Or, if we had on the flip side f of x and f of x minus 1, f of x minus 1 is making the y values happen one place later along the x-axis. So one place further along to the right. So that's what's going on. Try not to worry about it too much. Try and remember the rules there. The rules are important. Okay, before we get to examples then, I'm just going to say you can put translations together. So we could transform f of x to f of x plus a plus b. And the vector for that would be minus a, b. So, for example, if we had f of x minus 2 plus 3, and the vector for that translation would be 2, 3. So it would move positively to the right by 2 and positively up by 3 places. Okay, now we're going to have a look then at translating quadratics, cubics and reciprocals. Good times. Okay, first up then, so here we have a quadratic f of x, and we can see it crosses the x-axis at 2 and 6, the y-axis at 12, and it has a minimum at 4 minus 4. So, the graph shows f of x good times. Part A, then we want to sketch y equals f of x minus 4, labelling the x-intercepts and the minimum. So, f of x minus 4 is going to give us a translation 4 places to the right. So the graph isn't moving up or down at all. So, hopefully I can do something clever here. Copy the graph. So the graph isn't changing shape at all. It's moving 4 places to the right. So the left-hand x-intercept is actually going to cross at 6. And the right-hand x-intercept is going to be 4 places on from 6. So this guy is going to be 10. This guy, let's put a blue 6 in to show it belongs to the transform graph. So we should change the colour of the graph. There we go. Okay, and then the coordinates of the minimum, well, the x coordinate is just going to be 4 places on from 4. so it's going to be 8. And the y coordinate is going to be exactly the same, so it's just going to be 8 minus 4. So that is our sketch, y equals f of x minus 4. Good times. Okay, then part B wants us to sketch f of x plus 4. So this time the 4 is not inside the bracket, it's completely separate from the function, so this is a y translation. Positive 4 moves us 4 places up. So here we want to label the y-intercept and the minimum. So let's copy that, make it green. Okay, so this time the graph isn't moving left or right, it's just moving 4 places up. Now the y coordinate of the minimum was minus 4, so the y coordinate of the minimum is now going to be 0. So it's actually going to sit on the x-axis like that. Now the y-intercept is going to be 4 places up from 12, so the y-intercept is going to be 16, and the coordinates of the minimum are going to be 4, 0, like that. So that's how we translate quadratics. Okay, this time then we've got a cubic. So this guy crosses the x-axis at minus 3, 0, 7. It has a maximum at minus 1, 4, and a minimum at 3, minus 5. So, part A asks us to sketch y equals f of x plus 2, labelling x-intercepts, the maximum and the minimum. So this time I'm going to mention the vectors. So f of x plus 2 is a translation along x minus 2 places and then nothing up or down. So our translation vector is minus 2, 0. So our graph is just moving 2 places to the left. Doesn't want to play ball with it. Right. Okay, so it's not moving up or down at all. So it's gonna look something. Get a bit further over. Something like that. So now we just need to label the points that we're asked to label. So if we start from the right and work left, this x-intercept is now going to be at 5. This minimum is now going to be at 1 minus 5. This x-intercept is now going to be at minus 2. This x-intercept is now going to be at minus 5, and this maximum is now going to be minus 3, 4. Good times. So, there's our transformed graph. Okay, then for part B, we want to translate the function by the vector 0, minus 5, labelling the y-intercept, the maximum, and the minimum. So, what we are finding here is y equals f of x minus 5. So, this is a translation vertically downwards by 5 places. So, let's do just that. The reason this one doesn't ask for x-intercepts is that we don't actually know them, we can't work them out because we don't know the function. So, they will never ask us to do what we can't do. Although actually I made this one up. I will never ask us to do what we can't do. Okay. Right then, so this graph is going to look something like that. Although we do know that the y value of the maximum was 4. Now we're translating by -5, so we need to make sure that the maximum is now below the x-axis. So something like that. So now we just need to label our points. So naturally stuff is in the way down here. Let's just move this. Okay. So this minimum now has coordinates of, well, it has this x coordinate, so it's going to be, but it's gone down by 5, so it's now 3 minus 10. The y-intercept has gone from 0 down to -5, and now this maximum has the same x coordinate, so it's -1, but it's gone down 5 from 4, so it's -1, -1, like that. So there's our graph, translate vector 0, -5. Good times. Okay, now we need to look at translating reciprocals. Which I think we'll do in its own video because this one's getting quite long. So that's exactly what we will do in the next video. Hope to see you there. Take care, guys.